What is the height of the prism? This will be the height of the prism. Let me take like this. So the slant length is L. So this will be 30 degrees. So let me take this is say like a R. So cos 30 is equal to H by L. So H is equal to L root 3 by 2. So then what is the volume of the prism? Volume of the prism V naught should be equal to half into base length. Okay, base length is how much will be? Let me find out base length also. Sine 30 is equal to B by 2 by L. So B is equal to, it will be L. So what is the volume of prism? Volume of the prism will be half into BH into slant length. Okay, this one, there's an edge length here. This called like a edge length, this called like a slant length. So there's a formula. So altogether volume of the prism will be V naught equal to half into, what is B? B is L. What is H? L root 3 by 2 into L. So total volume, this will become equal to L square root 3 L. Okay, fine. I think this is the geometry everyone knows. Huh? You know, high school geometry, what you have come across. Half of it is immersed. Okay, let's get into the problem. So here is what I'll bring a prism. Half of it is immersed here. Slant length off of the slant length is immersed. There's everything is water. Go back to the fluid buoyancy concept and get that buoyant force. I'm giving plane diagram. Fine now. So half of this. So let me bring it. Well, the spring will be elongated. So that will be spring force. The weight will act. So let's take the sum. We have taken this length to be B by 2, no? This is B by 2, B by 2. And this total height is what we called it as capital H. Now some H length is what? Immersed. Some let's take this is X, this X. So this is 30 degrees. Now, what is our question? Force due to surface tension. Tell me how do it will act here? The contact angle between water and the glass is zero. Where the force due to surface? The force due to surface tension will act at these points. Only at 2 points or everywhere? Everywhere on this prism, everywhere that one. So it is immersed. Oh, I think this will be very challenging for you to really assume the diagram. So here, if you take that surface, no, the force due to surface tension will be acting will be like this. On the side faces, it will be in this direction, making an angle theta. Later on, I'll show the theta. I think you should have that imagination. Huh? On the slant face, the force due to surface will act along the slant. On this vertical faces, these are vertical faces, no? On the vertical faces, force due to surface will act vertically down because the angle of contact theta is zero. Able to notice that? Anyway, theta will be 30 degrees. That we know it. Theta will be how much? 30 degrees. So here, theta will be say 30 degrees. Okay, let's get the volume immersed here. So now, shall we? So what is telling of the slant face? Can we calculate this distance y sine 30? Let's get into some mathematics first. Sine 30 is equal to x by L by 2. So x equal to how much? L by 4. What is cos 30? Cos 30 is equal to y by L by 2. So y is equal to L by 2 cos 30. So L cos 30 root 3 by 2. So root 3 by 4. Okay, let's get the Bion force. So what are the things that are acting the weight of the prism, the Bion force? I'll show it somewhere here. There's the weight of the solid, weight of the prism, and spring force and the force due to surface. We have to equate all these things. Okay, first let's calculate the weight of the solid. Okay, fine. So after getting the weight of the solid, density of glass is D and that of water is rho. So he has given the densities also. Please look at here. The density of this is D, no? So therefore, first, what is the forces that are, first we'll calculate the weight of the prism. Anybody weight of the prism? Density is D. What is the volume of prism? V naught. Already we have checked it. Volume of the prism is V naught into G. So what is V naught? V naught is L square L root 3 by 4 into G. What is the Bion force? Bion force should be equal to density of water rho is given, volume immersed into G. What is the volume immersed? Volume of prism, volume of bigger prism minus volume of smaller prism. Because I think volume immersed, are you able to see? There's a volume immersed. This much is what immersed, no? The gray color, are you seeing the gray color? This is what the volume immersed, no? No, you see this. Even see anybody, even for me also, like I should fight with the diagram. There's no other way. How to calculate volume immersed? In the bigger volume, V naught minus volume of the smaller prism. What is the volume of smaller prism? this white color, or I'll put some yellow color. Now you can see this. Can you calculate volume of that yellow color? First, V naught, we know it. Rho Vi. V naught is how much? L square L root 3 by 4 minus. What is the volume of yellow color? Again, what is the volume of prism? Half into base length is 2x, height is y, and the edge length is L. So half into base is 2x, height is y, edge length is L into G. Is testing your geometry. To be frank, surface tension is already over once. If I draw this diagram, surface rest all everything is a geometry what we should know, or I should know. No, let me take the next part. Now what is x? L by 4. So 2 get cancelled. So L by 4. What is y? L root 3 by 4 into L into G. Rho L square L will come out. So root 3 by 4 minus root 3 by 16. Anybody value? 1 by 4 minus 1. Okay, 1 by 4 we can take outside, no? 3 by 16.
Sir, half into L by 4, sir.
Okay, here 2 get cancels, no? X is L by 4. Y is what? L root 3 by 4. Okay? Somebody asked a question, please reply, no?
Yes, sir.
You have to reply, no? I'm asking you. Yes, sir. Okay, fine. Then otherwise, what I'll be keep on shouting like this, huh? Okay, fine. Yeah. No. Okay. Small L square, capital L, you take it outside. So this will become. Okay, this is buoyant force, this one. Okay, now let's equate here. Everything we know. What is the force due to sufficient? How to calculate? What is this length? 2x. And what is this slant length is L? At corner, we are at corner. I think I'll bring one more page. It's getting congested.
Sir, FB must be 3 root 3 by 16.
Yes, sir.
Okay. Yeah, I'll adjust it. Yeah, thank you. Yeah. Well, I'll write it here. 3 root 3 by 16. Yeah. Root. Now, force due to surface tension will calculate. I'll bring the diagram so that you make observation. I'll bring the total diagram, that one. And now looking at this diagram, please, I think we can't, yeah. No. And let's write force due to surface tension. Force due to surface tension should be equal to 2x sufficiency 2x sufficiency plus this will be 2L 2 okay this will be L st cos theta and this will be how much again one more L st cos theta. Now why this 2x? This length, edge length here, what is this length? 2x, no? So because it will be immersed here. Then again, the liquid is in contact on this surface and here it will act along the what? Like it will wet completely. So it will act along the surface. Here force due to surface will be along y-axis. Here what happened? Along the slant length, along the slant surface. So therefore, I'm just showing it like this, this theta. So you should take component of that. So what is the force due to surface sufficiency into that length? Able to understand why these two terms, why this 2x, this length is 2x here. This is the edge length. What is the edge length? Edge length should be L. There's no other way. Either you imagine or draw the diagram. I'm making things clear. Either you imagine or draw the diagram. So now force due to sufficiency, this should be equal to 4x st 2L st. What is cos theta? 30 degrees. Cos 30 root 3 by 2. 4x plus L root 3. Okay, this is st. This is a force due to sufficiency. Okay, let's equate all the forces. What are the forces that are acting? Four x plus L root 3 st. I took outside common. I don't know. Somebody is asking 4 st. What is that?
Okay, sir, understood.
No, equate forces. So what are the forces? Spring force, buoyant force, weight, and force due to sufficiency. So spring force at equilibrium of prism. Net force due to sufficiency. That is this one. So here I think we have written Fs dash. I think it is correct. The resultant force is what we are showing like this. Now substitute all kx, buoyant force 3 root by 16, weight of the solid dl square L root 3, density, no? So density. What is x? X, I think we have, anybody? X, I think somewhere calculated, no? L by 4, no? It is, yeah. So this will be L by 4, L root 3 into st. So this will become L plus L root 3 into st. Sufficiency, I'm writing st. I think what is symbol S you might have given. So what is asking now? Find calculate the extension in the spring. So solve for x. Of all everything fine, force due to sufficiency is what student has to really bring the imagination. Okay, now I think in your home, many different types of shaped solid objects will be there, or you can make with some